Welcome back. Let's read about this old jet engine.
Pratt & Whitney JT8D. The Pratt & Whitney JT8D is a low bypass, 0.96 to 1 turbofan engine introduced by Pratt & Whitney in February 1963 with the inaugural flight of the Boeing 727. It was a modification of the Pratt & Whitney J52 turbojet engine which powered the U.S. Navy A-6 Intruder and A-4 Skyhawk attack aircraft. 8 models comprise the JT8D standard engine family, covering the thrust range from 12,250 to 17,400 pounds-force, 54 to 77 kN, and power the 727. 737-100/200, and DC-9. The updated JT8D 200 family, covering the 18,900 to 21,000 pounds force, 84 to 93 kN, powers the MD-80 and re-engined Super 27 aircraft. The JT8D was built under license in Sweden as the Volvo RM8, a redesigned afterburning derivative for the Saab 37 Viggen fighter. Pratt & Whitney also sells static versions for power plant and ship propulsion as the Foot 8. Design, edit. This section needs additional citations for verification. Please help improve this article by adding citations to reliable sources in this section. Unsourced material may be challenged and removed. October 2008. Learn how and when to remove this message. The JT8D is an axial flow front turbofan engine incorporating a 2-spool design. There are 2 coaxially mounted independent rotating assemblies, one rotating assembly for the low-pressure compressor, LPC, which consists of the first 6 stages, i.e. 6 pairs of rotating and stator blades, including the first 2 stages which are for the bypass turbofan, driven by the second, downstream, turbine, which consists of 3 stages, and a second rotating assembly for the high-pressure compressor, HPC, section, which has 7 stages. The high-pressure compressor is driven by the first, upstream, turbine, which has a single stage. The front-mounted bypass fan has 2 stages. The annular discharge duct for the bypass fan runs along the full length of the engine, so that both the fan air and exhaust gases can exit through the same nozzle. This arrangement allows some noise attenuation, in that the still hot fast-moving turbine exhaust is shrouded in much cooler and slower-moving air, from the bypass fan, before interacting with ambient air. Thus, the JT8D noise levels were significantly reduced from previous non-turbofan engines, although the low bypass ratio meant that, compared to subsequently developed turbofans, high noise levels were still produced. Within the fan inlet case, there are anti-icing air bosses and probes to sense the inlet pressure and temperature. Similar units exist throughout the engine to check temperatures and pressures. At the 13th, i.e. the final, compressor stage, air is bled out and used for anti-icing. The amount is controlled by the pressure ratio bleed control sense signal, PRBC. The diffuser case at the aft end of the compressor houses the 13th stage. Its increasing cross-sectional area allows the compressed air to slow down before entering one of the engine's 9 burner cans. Again, there are 2 bosses to extract 13th stage air for anti-icing, de-icing of fuel, and airframe, cabin pressurization, use. Not all the compressed air enters the burner cans at the fuel ignition point. Some bypasses the can completely and cools the first turbine stage, and some is gradually introduced into the burner can's perimeter in such a way that the burning fuel is held near the can's centerline. There are 9 combustion chambers positioned in a can-annular arrangement. Each chamber has 3 air inlet hole sizes. The smallest is for cooling, The medium is for burning and the largest for forming an air blanket. 1. Details. 2. Cannula combustor. 3. 20 in, 510 mm, diameter rotor and bypass stator. 4. Compressor fan. 5. Fan blade. Update programs, edit. In response to environmental concerns that began in the 1970s, the company began developing a new version of the engine, the JT8D 200 series. Designed to be quieter, cleaner, more efficient, yet more powerful than earlier models, the -200 series power plant was re-engineered with a significantly higher bypass ratio, 1.74 to 1, covering the 18,500 to 21,700 pound force, 82 to 97 kN, thrust range and powering the McDonnell Douglas MD-80 series. This increase was achieved by increasing bypass fan diameter from 39.9 inches, 101 centimeters, to 49.2 inches, 125 centimeters, and reducing fan pressure ratio from 2.21 to 1.92. Overall engine pressure ratio was also increased from 15.4 to 21.0. Since entering service in 1980, more than 2,900 of the -200 series engines have been produced. The JT8D 217 and -219 engine, S, were tested in 2001 and were deemed suitable replacements for the old TF-33 engines on military and commercial aircraft as part of the Super 27 re-engining program. The updated engines offer reduced, Stage 3, noise compliance standards without the need for hush kits, enhanced short field performance, and steeper and faster climb rates with roughly a 10% reduction in fuel burn for extended range. Pratt and Whitney, in a joint venture with 7Q7, SQS, and Omega Air, developed the JT8D 219 as a re-engine power plant for Boeing 707-based aircraft. Northrop Grumman used the -219 to re-engine one of the United States Air Force's fleet of 19 Joint Surveillance Target Attack Radar System, E-8 Joint STARS, aircraft, which would allow the STARS more time on station due to the engine's 17% greater fuel efficiency. However, these plans were cancelled after the single conversion when the decision was taken to retire the platform. NATO originally planned to re-engine their fleet of E-3 Sentry AWACS aircraft, however again this was cancelled after the decision was taken to retire the E-3 platform in preference for the E-7 Wedgetail. The -219 is publicized as being half the cost of the competing 707 re-engine power plant, the CFM International CFM56. For reasons of geometrical and balance similarity to the engine it is replacing and the associated relative upfront wing modification costs of the two choices. The proposed Ariane SBJ supersonic business jet, previously under development, was to use a pair of JT8D 219 engines for sustained supersonic flight. Variants, edit. Series initial J52 derived variants updated -200 series. Model -1, a /B, /7, a /B. /9, a /11-5-15, a -17, a /R, -209-217, a /C, -219. Certification the 1st of February 1963, the 7th of April 1971, the 1st of February 1974, the 22nd of June 1979, the 31st of October 1980, the 22nd of February 1985. Compressor axial 13 stage, axial 14 stage. Combustors, turbine 9 cannula, 4 stage. Maximum thrust 14,000 15,000 lbf. 6267 kN 12,250 lbf. 54.5 kN 15,550 lbf. 69.2 kN 17,000 17,400 lbf. 7677 kN 18,900 lbf. 84 kN 20,000 lbf. 89 kN 21,000 lbf. 93 kN. Length 123.56 in. 3,138 millimeters. 154.20 in. 3,917 millimeters. Width 40.0 in. 1,020 millimeters. 49.2 in. 1,250 millimeters. Dry weight 3,205 3,402 pound. 1,454 1,543 kilogram 3,205 pound. 1,454 kilograms 3,414 3,474 pound. 1,549 1,576 kilogram 3,433 500 pound. 1,560 1,590 kilogram 4,588 pound. 2,081 kilograms 4,623 4,684 pound. 2,097 2,125 kilogram 4,684 pound. 2,125 kilograms. LPRPM 8,600 8,500 8,800 8,800 to 8,900 7,850 7,770 to 8,080 8,120. HPRPM 12,250 12,100 12,250 12,250 to 12,280 12,150 12,285 to 12,350 12,350. Production, edit. More than 14,000 JT8D engines have been produced, totaling more than 1/2 billion hours of service, with more than 350 operators, making it the most popular of all low-bypass turbofan engines ever produced. Regular production ended in 1985, but some replacement engines were produced for military aircraft in 2011. Mainline airline use of the JT8D continued until 2020 when Delta Airlines retired their MD-88 fleet early due to the COVID-19 pandemic. Applications, edit. 1 Ariane SBJ proposed, not built. 2 Boeing 707 Re. 3 Boeing 727, Re-engine Super 27s have JT8D 200s. 4 Boeing 737-100/200. 5 Dassault Mercury. 6 Kawasaki C1. 7 McDonnell Douglas DC-9. 8 McDonnell Douglas MD-80 series, JT8D 200s only. 9 McDonnell Douglas YC-15. 10 Northrop Grumman E-8C Joint Star Single Test only. 11 Sud Aviation Caravel 10B, 10R, 11R, and 12. 12 Pratt and Whitney Foot 8 Mobile Pack and Swift Pack Mobile Generators. 1 Installations. 2. Boeing 727. 3. Boeing 737. 4. Dassault Mercury. 5. Kawasaki C1. 6. McDonnell Douglas MD-80. 7. Sud Aviation Caravel. Accidents, edit. The 18th of January, 1969. United Airlines Flight 266. 10 minutes after takeoff, the cockpit received a warning from Engine 1 of an engine fire and cut off power to that engine. A minute later, Flight UA266 suffered a total loss of electrical power, which disabled the aircraft's flight instruments. At 13 minutes after takeoff, the plane crashed into the Pacific Ocean, just 12 miles off the coast, killing all 38 people aboard the aircraft, which consisted of 32 passengers and 6 crew members. The 4th of April, 1977. Southern Airways Flight 242. Both engines on the DC-9 failed when the pilots flew into a severe thunderstorm after misreading their onboard radar. The flight encountered severe rain and hail. The NTSB concluded that the loss of thrust was caused by the ingestion of massive amounts of water and hail, which in combination with thrust lever movement induced severe stalling in and major damage to the engine compressors. Some 63 people on board and 9 on the ground died as a result of the accident. The 22nd of August, 1985. British Airways Flight 28M, an engine failed during takeoff from Manchester Airport and a fire spread into the cabin, resulting in 55 fatalities aboard the Boeing 737-236 Advanced. The 6th of September, 1985. Midwest Express Flight 105. The NTSB concluded that an unconfined failure of the 9th to 10th stage compressor spacer occurred immediately after takeoff from Milwaukee Mitchell International Airport, then called Billy Mitchell Field. The plane was observed to have slowed significantly as a result of the engine loss and experienced an accelerated stall condition. The plane rolled to the right 90 degrees and crashed just south of the runway, resulting in 31 fatalities, all passengers and crew, aboard the McDonnell Douglas DC-9 aircraft. The 3rd of May, 1991. Ryan Airlines unconfined failure of 9th stage compressor disc penetrated fuel lines and fuselage on the tarmac at Bradley International Airport, causing fire and complete loss of aircraft. No fatalities reported. The 27th of December, 1991. Scandinavian Airlines Flight 751. The engines on an MD-81 ingested wing ice during takeoff, causing engine damage that led to a total loss of thrust on both engines. The aircraft crashed in a forest clearing with no fatalities. The 6th of July, 1996. An engine explosion happened on an MD-88, Delta Airlines Flight 1288, just prior to takeoff at Pensacola, Florida, USA, with 2 fatalities. The 6th of March, 2003. A 737-200 operated by Air Algérie crashed due to sudden loss of thrust as a result of the left engine's fan blades fracturing and the captain taking controls off of the first officer without assessing or mentally preparing for the situation. All 6 crew and 96 of the 97 passengers were killed. The 7th of November, 2007. Nationwide Airlines Flight 723. The right-hand engine of a 737-200 detached from Flight 723 during rotation. The pilots managed to execute an emergency landing, saving all 112 passengers and crew on board. The 15th of April, 2008. Huabora Airways Flight 122. A DC-9-51 operated by Huabora Airways crashed and burned at Goma following an engine fire, with 40 fatalities. The 2nd of July, 2021. Tronsar Flight 810-1 engine on the Boeing 737-200 cargo aircraft failed en route from Honolulu to the neighboring Hawaiian island of Maui. The crew attempted to turn back to Honolulu's Daniel K. Inouye International Airport, but the plane's second engine overheated, forcing the two pilots on board to ditch the airplane about 4 miles, 6.4 kilometers, off the southern coast of Oahu. Both pilots were rescued by the United States Coast Guard. The 19th of October, 2021. 2021 Houston MD-87 crash. A privately owned MD-87 was recorded on its takeoff roll just after throttling up. A puff of smoke was observed from the left engine nacelle. Subsequently, the aircraft rolled off the end of the runway into a grass field and caught fire. The MD-87 was almost completely destroyed by the resulting fire. The privately owned jet, N987AK McDonnell Douglas MD-87, owned by J. Allen Kent Development LLC, was operating a charter flight carrying sports fans to Boston for the ALCS Championship baseball games. Only one minor injury and no fatalities occurred in this incident. It is still under active investigation. Specifications: JT8D 219, edit. Data from General Characteristics. 1 type, dual spool, low bypass turbofan. 2 length, 154 in, 390 centimeters. 3 diameter, 49.2 in, 125 centimeters, fan. 4 dry weight, 4,741 pound, 2,150 kilograms. Components: 1 compressor, axial flow, 1 stage fan, 6 stage LP, 7 stage HP. 2 combustors, 9 cannula, chambers. 3 turbine, 1 stage HP, 3 stage LP. Performance: 1 maximum thrust, 21,000 lbf, 93 kN. 2 overall pressure ratio, 19.4. 3 air mass flow, 144.7 kg /s, 19,140 pound /min, 4-9, 211.83 kg /s, 28,020 pound /min, 4-109. 4 fuel consumption, 19% reduction over JT3D. 5 specific fuel consumption, 22.661 g/kns, 0.8000 pound /lbfh. 6 thrust to weight ratio, 4.43. See also, edit. Related development: 1 Pratt & Whitney J52. 2 Volvo RM8. Comparable engines: 1 Kuznetsov NK8. 2 Rolls-Royce SPI. 3 Solovyev D30. Related lists: 1 List of aircraft engines. References, edit.